Alrighty, this short video is on literal equations. It's lesson 2.07 in your algebra content for Florida Virtual School, and hopefully this will help you understand a little bit about how to solve literal equations. When we solve literal equations, these are our goals. So remember, when we're talking about our scale, this gives us an idea of what we need to learn to master this concept. And so we always go up with our scale, level 2 being our lowest or the least amount of knowledge, and then level 3 being your standard or what you need to learn. So level 1 says I will be able to identify what a literal equation is. Level 2, I will be able to solve one step. So you can do one-step literal equations. And then number 3, or level 3, says I will be able to solve any equation for a specific variable. So we'll look at all 3 different types of levels in these questions provided tonight. Okay, so this is just a few steps that you could follow when you're solving a literal equation. Now, keeping in mind a literal equation is something, it's an equation that has a bunch of letters. There are a lot of variables, and it's just basically asking you to rearrange something so that you're solving for a specific variable. So we may want to write these steps in your notes if you want to pause the screen, but step 1 says that you locate the variable you are asked to solve for in the box. in the equation, and I typically put that in a box, and you'll see me do that in these examples. Step 2 says identify the operations on this variable and the order in which they are applied. Now that's kind of confusing. So what they mean by that is operations. They're saying identify, are you adding, are you subtracting, are you multiplying, or are you dividing? And so if you can figure out what you're doing, you're always going to do the opposite. And that's what they mean in step 3 when it says use inverse operations. Remember, that's a fancy way to say do the opposite, to undo operations and isolate the variable. And so these steps might be a little confusing, but we'll go through some examples and hopefully that will help. All right, I liked this one as just a reminder of the steps. This is another example here. We're solving ax plus b equals c. So we're getting x by itself here. I always like, as my first step, is just to find what I'm trying to get by itself and put a box around it. So let me do this in a darker color here. So ax is the last thing that we will touch, so everything else needs to be moved over first. And so notice that's why we're moving the b over first. And I like their steps, so they tell you move the b first. That's the opposite of addition, so that's why we're that's why we're subtracting b from both sides. So that's our first step. And notice that's where this came from. And then you're left with your box a times x. And notice there what they did. They took the a and they divided by a. And they did this because ax is the same thing as a times x. And the opposite of multiplication is to divide. And so that's why they chose to divide here. I like how they put that in there for you for your steps. And then x is what we are solving for, and it stands alone. So once x is by itself, you are done. So I like these steps. So this might be something you may want to write in your notes. So you can pause this to write this part in your notes. So I first wanted to start by looking at something we know and then compare it to what a literal equation is. So if you look over here on the right, it says solve for x, and that's something we've seen before. So we want to take that equation, which is 3 times x equals 9. We want to solve that to get x by itself. So what we do is we look where the x is, which is attached to the 3. And we see that it's being multiplied. And we know that if we want to get x by itself, we always do the opposite. And so when we're working through this problem, we need to do the opposite of multiplication, which we know is division. So we're going to divide both sides by what's with the x, which is the 3. And when we do that, 3 divided by 3 cancels, and we're left with x equals, and then we have 9 divided by 3, which is 3. So we know in this problem our answer is x equals 3. We've done this before. That would be our answer. Now let's use the exact same steps, the same way we solved that one, to do this next question, which is considered our literal equation. Remember, a literal equation pretty much just has variables or more than one variable, and we're trying to solve for one of them. We're rearranging. So this side is a literal equation, but we're going to use the right side as our guide. It's the same type of idea. So in this case, what we have is we have a times x equals b. And our goal here is still to get x by itself. And we know that x is attached to the to the a. Notice the same thing for 3 times x, same box. So we do the exact same thing. We see that it's multiplication, and we know that if we want to solve to get x by itself, we do the same thing we did on the right, and we divide both sides. Now on the right, we divided by 3, and the reason we divided by 3 is because it was attached to the x. Here we want to do the same thing. We want to divide by whatever's attached to the x, which is a. When we do that, a divided by a cancels, and what you'll see is you're left with x equals b over or divided by a, and that's your answer. Keep in mind, nothing's changing. The process of solving an equation is the exact same thing. It's the same thing we did on the right that we did on the left. The only difference is you're used to seeing numbers, where now we just have variables. Let's try some others. Okay, so here's some foreshadowing, something that you're going to see in Module 3. But in Module 3, you will learn about slope-intercept form. Slope-intercept form is y equals mx plus b. Okay, so let's think about this. So y equals mx plus b. And we want to solve this to get m by itself. So I'm going to suggest the first thing you do is find the m and you put a little box around it. That means that's the last thing we're going to move over, but we need to get m by itself. So that's the last thing I'm going to do. So that means I'm going to look on that side of the equation and I see a plus b that I need to move over. And because it's a plus b, I'm going to move it to this side. I want to get m by itself. So everything else has to be moved over. So if that's a plus b, we do the opposite. And we know that the opposite of a plus b is subtract, or a minus b. So that'd be the very first step. So that's the opposite of addition. Okay, so right now what we have is we have y minus b equals mx. Now we can't do anything here because we have a bunch of letters. They're not like terms, so all we can do is leave it as y minus b. Okay, so now remember our goal. Look back at your goal. Your goal was to get m by itself here. So what we want to do is we want to look here. Now we have m times x. So now we can actually get m by itself here. We need to get rid of the x. So to get rid of the x, we ask ourselves, what's going on? What operation? Are we adding? Are we subtracting? Are we multiplying? Or are we dividing? And you can see here that we're multiplying. And we know that we have to do the opposite to get it by itself. So if we're multiplying, we know we have to do the opposite, which means we are going through and we're dividing. We're going to divide both sides by whatever's with the m, which in this case is an x. Now when we do that, the x's cancel, and we are left with m on this side and y minus b over x on this side. And so that should be your answer. So let me write it over here for you. So your answer would be y minus b over x. Now sometimes you may not see it written like that. Sometimes you could even see it written like y over x minus b over x equals m. Both of these mean the exact same thing. Notice the only difference is that you're taking the x and you're sharing it with everything in the numerator. So both of these answers would be equivalent or the same thing. Let me put an or in here between these two so you know. And that would be your answer. All right, so this question says, solve the inequality. P is greater than t plus x over c. Now in this case, we're trying to get x by itself. Now what you'll notice is that it's a division and there's a divide by c. That's what makes it nasty. We don't really like that part of it. So if this is to divide by c and we do the opposite, that's almost like we are multiplying. Remember, we always do opposite. So if that's the case, really what I need to do is I need to get rid of that divide by c. So that means I really need to multiply c by both sides. So multiply by C, multiply by C. Now when we do that, what you'll see is this C and this division and this multiplication in C will cancel. And you are left with C times P is greater than T plus X. Okay, now once we've done this, our life is a little bit easier because we know we're trying to get X by itself, which is right here. And so we need to move this T over, this positive T. And so to move a positive T over, we do the opposite, which means if it's a positive T, to bring it over, we subtract T. That's the opposite. So what we're doing now is we're going to subtract T from both sides of our inequality. All right, so what we have on the left side of our inequality is CP minus T. Just kind of going in order. I'm keeping this together, then I'm bringing this. All right, bringing my sign down. The T minus T cancels. That becomes 0. It goes away. And then you're left with X. And all this question is asking you to do is solve to get X by itself. So this is your answer. Okay, we've seen this formula before. This is the formula for finding the volume of a cylinder is V equals pi r squared times height. Now, when we're doing literal equations, it's very important that you pay attention to your operation. And what that means is if you're looking at all of these, you're noticing that they're being multiplied because that's important because when you're doing literal equations, you always want to do the opposite of whatever the operation is. And so you have to keep in mind, are they adding, subtracting, multiplying, or dividing? All right, so in this problem, we want to solve. It looks like to get r by itself. So we know we're going to do the opposite, which means we are going to divide. That's the opposite of multiply. And we're going to take everything but the r and we're going to move it over. So I'm going to take the pi and I'm going to take the h. So break, cancel, 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 pi, and h. All right, now let's see what we have written left. What's left? Well, I think right now it looks like we have v over pi times h equals r squared. We're almost done. R is almost by itself. Now this one I put in here just because I don't want you to get tricked, but anytime you see a square like this, the opposite of that is the square root. So these are opposites of each other, and it's very important we know our opposites when we're doing literal equations. The opposite of a plus is a minus. The opposite of multiplication is division. What you just talked about now, or what we just brought up, is the opposite of a square is the square root. So these are all of our opposites so far that we've looked at. So in order to get r by itself, we have to do the opposite, which means we take the square root. So I'm going to take the square root of both sides. All right, when I do that, I am now left with the square root of v over pi h, and that's going to be equal to r, and that's because the square root and the squared cancels out. And if we look, this question says to solve for r, get r by itself, and we just got r by itself, so this is our answer. Remember, literal equations is just rearranging letters to make that variable isolated or by itself. Alrighty, this question says the area of a trapezoid can be found by the formula A equals 1/2 times h, which is the height, and then in parentheses b1 plus b2. So let's just kind of give you a visual. This picture here represents a trapezoid, and remember b1 and b2 are just bases of that trapezoid, and then h is your height. Just remember, oh gosh, I can't make a straight line for the life of me. It has to be a 90-degree angle, so that's your h. It could also be found here on this side. Both of those would represent h. So that just gives you a visual. You do not need to know that to be able to solve it, but now what our goal will be is to get b1 by itself. Now there's a couple of ways to do this, so you will see teachers solve this differently, but we're going to do it step by step this way. So this is one way to do it. All right, so I'm just going to go and get rid of each item by item. So if we have a 1/2 here, I know that I can get rid of a 1/2 by either dividing by 1/2 or by multiplying by 2 over 1. That's the reciprocal, recipe-flippy, that's what I call it, reciprocal. Remember, reciprocal is when you flip your fraction and you multiply both sides of your equation by that. So let me draw my equation line through this so you can see. So we're doing that because if you notice, 1 times 2 is 2, and 2 times 1 is 2, and 2 divided by 2 is 1. So those cancel each other out. So when we do that, we are left with 2a over 1, or 2a. And then on this side, we have h times b1 plus b2. Now, notice in here, this is a multiplication. And our goal is to get b1 by itself. So we're getting closer. We need to get rid of that h, though. You could distribute the h here if you wanted to, but it wouldn't really help us much. So I'm going to actually go ahead and divide everything by h. And remember, I'm dividing because this is multiplication, and I always do the opposite. So this cancels with this. And now we're left with 2a over h is equal to b1 plus b2. And then you can put that in parentheses if you want. Parentheses here now in this step would just be for organization. All right, one step left. So our goal is to get b1 by itself. So we need to move this b2 to the other side of the equation. So if that's a plus b2, we do the opposite, which tells us we subtract it. I'm running out of space here. This problem's a little lengthy. Okay, these would cancel. I'm going to write my answer here. And so notice that b1 is now by itself. And then on the other side, we have 2a over h minus b2. So this would be our answer for this specific problem. Remember, there are multiple ways to write this. This is just one way. Okay, so here's an inequality. It says solve for m. Take note on this one because you will have one similar to this on your quiz and on your test. So let's go through this. So 15d minus 5m plus 6k is less than 7d plus 9k. So if you want to write this in your notes, it would be a good idea. Notice that we're solving for m here. We're trying to get m by itself. So I'm going to box the whole term that has an m so I know what I'm saving to move over the last bit. That's the part that should be by itself. Everything else needs to move over. Also notice that I took that minus sign inside of the box. And remember, we're doing that because a minus sign belongs with the number behind it. So that's like a -5. All right, so the box is the last thing that we're going to touch. Everything else we have to move over. So I'm going to move the 15d over, that whole unit. And to move that over, we treat this just like an equation, move it to the other side. And since it's a positive 15d, to move it over, we subtract it. And I'm going to go ahead and put it right underneath the 7d because those are considered like terms. And remember, a like term has the same variable with the same power. All right, so 15d and 15d cancel. And I can bring down my -5m. My plus 6k. Okay, now we're doing 7 minus 15 gives us -8d, and then we can bring down the plus 9k. Now, you can't add these things together yet, these terms yet, because they're all different, but we're almost there. Remember, our goal is to get m by itself. So let's go ahead and box that again. That's the last thing I can touch. So now if we look here, that means that we have this plus 6k we need to bring over. And if that's a plus, to bring that to the other side, we do the opposite, which means we subtract. I'm going to put it right underneath this 9k because they both have like terms. Same variable. So 6k minus 6k cancels on the left. And right now you are left with -5m less than -8d. And then 9 minus 6 gives us a positive 3k. Okay, last step. So we have -5 times m. Now we have m by itself, that unit, that term. And we want to get m by itself. So if it's -5 times m, remember we are always doing the opposite operation. So if this is a multiplication, we're going to divide. And this is something they're testing here. Now, a couple of things. Make sure that you're dividing everything by -5, both of these terms on this side. Also, make sure that when you have a negative number like this with your variable, and you're talking about an inequality here, you have to take this sign. And this is a less than sign, so now you have to take it and you have to flip it, and it becomes a greater than symbol. So I'm going to write our answer over here. These -5 divided by -5 is 1, so we have m. Remember, we flip our sign because it's -5. Then we have a -8d divided by a -5, and those two negatives become a positive 8d over 5. And then here we have a plus 3k over -5, which is the same thing as a minus 3k over 5. And you could have written it as a plus 3k over -5. That's the same. And so this would be your answer.